Energy innovation, so new ways of producing and consuming energy, will be absolutely critical to addressing climate change. When you ask school children what they might do to address these problems of global greenhouse gas emissions, they might talk about solar-powered flying skateboards as this kind of great innovation which would produce a sustainable transportation system. We need to move very rapidly towards much more efficient devices, applications and technologies to turn energy into the useful services that we enjoy. My name is Charlie Wilson. I'm a lecturer in energy and climate change at the Tyndall Centre for Climate Change Research at the University of East Anglia in the UK. And I'm also a visiting research scholar here at the International Institute for Applied Systems Analysis, IASA, just outside Vienna. Together with one of my colleagues here at IASA, Arnulf Grubler, we have recently published a book on energy technology innovation, and that's what I want to talk about briefly in this blog. We looked at 20 different innovation histories for energy technologies across a very wide range of countries, wide range of time periods, and wide range of technology types. To give you a few examples, we looked at solar photovoltaics globally, we looked at wind power in Europe, we looked at heat pumps in Switzerland and Sweden, we looked at ethanol in Brazil, we looked at hybrid cars in China, we looked at energy efficient appliances in Japan, and so on and so on. And we looked systematically at these different innovation histories to find out what we could learn about what works and what doesn't. So in the historical innovation case studies that we looked at, there were some innovations which were clearly more successful than others, and there were others which, although not complete failures, were definitely less successful in terms of their market outcomes. So let me give you an example of each. Wind power in Denmark. The industry began growing in the late 1970s and grew consistently, steadily and increasingly strongly all the way through to today. Denmark, one of the smaller countries in Europe, is the world leading manufacturer of wind turbines. I mean, it has a dominant global market position even today. So this is phenomenal success for a relatively small country. And the secret of its success lies in how it supported and sustained innovation in the wind industry. And so we look at that, for example, in detail at one of our chapters. Take an example of a relative failure. We looked at the production of synthetic liquid fuels in the US in the 1980s. So what do I mean by synthetic liquid fuels? Our transportation system runs basically on oil. So the kind of dominant liquid fuel that powers the world's vehicles is oil or oil-based. In the early 1980s, because of the concerns both about the price of oil and about the availability of oil, the US and other countries invested heavily in alternatives. So they tried to develop technologies to create liquid fuels from coal, for example. Coal, very abundant resource. Now, the way they tried to do it in terms of how they supported innovation in the US during that period for this synthetic fuels program was not ultimately successful. And there were many reasons why. And those are the kinds of reasons that we look at in our book when we're trying to see what is it that characterizes successful innovation historically and what's missing when you look at examples that haven't been as successful. The kind of key finding that we got from this systematic analysis was that it's the innovation system that's important rather than specific innovation processes. Okay, so what do I mean by that? When you read about innovation, when you talk to technology developers, when you talk to policymakers trying to support innovation, people tend to focus on something relatively specific, a specific process. An example would be what are called learning or learning curves. So this is this very simple idea that as you have more and more practice and more experience at doing something, you get better at it. Stands to reason. And historically, you can look at evidence of this and see that the more and more that you produce of a technology, the lower and lower the cost of that technology tends to be. And these are called learning effects. Now, there's an awful lot of analysis that's focused specifically on learning effects, both historically and when thinking about climate change mitigation. But those studies which zoom in on learning as an innovation process forget that there's all sorts of other things in the broader innovation system that enable those learning effects to happen. So, for example, we found good evidence across our historical case studies that learning effects are dependent on shared expectations among technology developers, policymakers, and end users in the market. Learning effects are dependent on clearly articulated preferences of the users of those technologies. Learning effects are contingent on mechanisms to share and exchange knowledge that's been gained through experience. Learning effects are dependent on having stable workforces, so there's not key engineers and managers and workers leaving and coming in with the knowledge in their heads lost and then having to be regained. So you've got stable workforces in stable industries that aren't exposed to kind of boom and bust or cyclical activity. So these are all examples of elements of what we call the innovation system, which enable this innovation process, learning, to happen. The problem is what happens in analysis and policy which doesn't recognize the broader system is that it zooms in on the process and says, we can learn from experience and costs will come down. So if we incentivize or subsidize more and more experience, costs will come down in a kind of deterministic way. That omits the importance of this broader innovation system and therefore essentially risks creating a policy that will not be effective. So those four elements, knowledge, adoption and use, actors and institutions, and resources, are the pieces of the puzzle. And you put the puzzle together and you see the whole innovation system, and that's what explains successful innovation outcomes. We think and we dedicate the final two chapters of our book to showing how our analysis can be useful in the efforts to try and mitigate climate change. There are already substantial amounts of investment, both of money, but also time and effort and brain power in trying to guide innovation towards low carbon outcomes. And it's not all successful. We don't think it's all successful. We think it can be more successful by taking some of the lessons from our book, that you need to focus on innovation systems and not innovation processes, specific innovation processes. And when you're focusing on all the different elements of this system, all the pieces of the puzzle, those elements need to be aligned and consistent. They need to be pulling or pushing in the same direction. Too often you see either contradictions between things going on in an innovation system, or you just see an overemphasis on one part with a sort of, let the other stuff sort itself out. So we argue very strongly for policy which is systemic. So what does this mean? This means that you need to invest in knowledge generation through research and development, but you also need mechanisms to share and exchange and store that knowledge. You need to stimulate market demand through subsidies and through incentive programs and so forth, but you also need to ensure that there are shared expectations among the technology developers and the companies pushing these technologies onto the market. What this generally tends to mean is that diversity, experimentation, variety and so forth are all good things as long as we have some tolerance of failure. We can't expect everything to work. But we would characterize successful innovation for climate change mitigation very much as being not about silver bullets, one technological solution, but about silver buckshot, this kind of scattering of innovation efforts across all these many different kinds of technologies. So these are the kinds of lessons that we can draw from our analysis that are profoundly relevant to existing innovation efforts. And so we hope our book will be read by policymakers as well as researchers like ourselves on innovation. So the book came out in May of this year, May 2014. It's published by, here you go, here's a nice real-time demo. It's published by Cambridge University Press, and you can find all the details of the book on the Cambridge University Press website. And we also encourage you, if you come to the IIASA website, that's iiasa.ac.at, and you look on the IIASA website for energy technology innovation, you will find a whole series of web pages also dedicated to the book and provide you some sample material and so forth. And as I said, my name's Charlie Wilson, and the co-editor of the book was Arnulf Grubler. So these case studies that we compile and edit in our book and add our kind of interpretations to are drawn from work that was begun under the Global Energy Assessment. And so the authors, the 24 co-authors of the book, were all involved in that process.